Okay, in this exercise, what we're going to try to do is start with a function. And clearly, we're starting with a function that's not linear, so we're definitely out of chapter 1. And do the kinds of plugging into this function that you're going to have to do in calculus and everything afterwards. And we're just going to run through the kinds of types. The very first thing you would have to do would just be plug in a number. So if I plug in 2, what that's asking me to do is just put a 2 wherever I see an x. So this is going to be 5 times 2 plus 1, and then 2 times 2 plus 3, like that. Now, there's probably not a single situation where you shouldn't simplify, so we're going to simplify, and we're going to get 11 on top, and we're going to get 7 on bottom, and that's the best answer. You can find the decimal equivalent, but that actually makes it worse, so let's not do that. So that's the first example, is just plug in a number. All right. The second example is plug in a different number. And this one we're being asked to plug in negative 1.5. So I'm going to put a negative 1.5 on top. I'm going to put a negative 0.5 on bottom. Negative times negative 1.5 on bottom, like this. There's not a situation where we shouldn't simplify. Some of this is going to be negative 7.5, so that's negative 6.5 on top, which is good. I'm going to get negative 3 plus 3 on the bottom. That's bad. Right? What does that say? That says we can't plug negative 1.5 into this function. So it really means two different things. As an answer, what we should say is that this is undefined. And let's just write that out. Later, in the context of domain in a section or two, what we really mean is that x equals minus 1.5 is not in the domain of the function because we can't even plug it in. So that's the second thing that can happen. The first thing that could happen is you plug in a number, you get an answer. The second thing is you can try to plug in the number and you get no answer at all. And it's very important to recognize that as saying the function is undefined there. All right. The third kind of thing they actually want us to do is what happens if we take the function and we just add 2 to the whole function. Now you probably remember that in terms of the graph, that just lifts the whole function up, but this section is about algebra, so we're going to do the algebra. So I'm just going to write down what g of x is. It's 5x plus 1 over 2x plus 3, like this, and then I want plus 2. I want to get a common denominator. The common denominator is 2x plus 3. So I'm going to multiply this 2 over 1 times 2x plus 3 on the top. And then 2x plus 3 on the bottom. And writing out all the little work, we're going to get 5x plus 1 plus 4x plus 3, no, 4x plus 6. Like this, all over 2x plus 3, like that. And what we're going to get, I think, is 9x plus 7, all over 2x plus 3, like this. Let's box our answer in, and we have successfully added 2 to our formula for the original function. This also gets used a lot. I'm just going to sort of recap. Plugging in numbers is important. Recognizing when you can't plug in a specific number is important. Adding a constant to a function is very important. Now let's do the next kind of plugging in. They did have you practice this in college algebra, every single one of these skills. We're just trying to collect them all up and see what we can do. The next thing they want us to do is find g of x plus 2. Now you might remember, and we'll do this certainly graphically later, that takes the graph of g and moves it 2 units to the left. But this one's about algebra, so what is this asking us to do? It's asking us, wherever we see an x in the original function, put an x plus 2. So we're going to do that. I have 5. Instead of x, I'm going to have x plus 2. And then I have my plus 1. On the bottom, I'm going to have 2 times x plus 2 plus 3. Like that. And no one ever is just going to let us leave it like that. So I'm going to simplify the top. I'm going to get 5x on top plus 10 plus 11, like that. On the bottom, I'm going to get 2x, and that's going to be plus 4 plus 3 plus 7. And there's our final answer. We get 5x plus 11 over 2x plus 7. Algebraically, it doesn't seem to look a whole lot like that function, but you're going to have to do this in calculus a lot, and you're probably going to have to do that in almost every science and economics. People like to move graphs left and right, and what we just did was the algebra that would accomplish that. So that's something we need to be good at, and that's something we need to practice. All right. Finally, the last thing we're going to have to be able to do is evaluate expressions that look like g of x plus g of 2. And you're going to see, by the way, that this gives a very different answer than the one we just got. What does this ask us to do? It says, write down g of x, so we'll do that. That's 5x plus 1 over 2x plus 3 plus g of 2. Now we already did that one, and we know that in advance I'm going to get 11 on top, I'm going to get 7 on the bottom. And I have to add those two things together. Well, I need a common denominator, so here we go. I'm going to have to go way over here to do this. I'm going to have 5x plus 1. The denominator it already has is 2x plus 3. But it's missing a 7, so I multiply the top and the bottom of that one by 7. See if I can do this right. And then plus, I have my 11 times 7. Now that one's missing a 2x plus 3 in the bottom, so I have to multiply the top by 2x plus 3. And the bottom by 2x plus 3. And what we're going to get is a big giant fraction whose bottom is 2x plus 3 times 7. And I'm going to multiply the tops here. I'm going to get 35x plus 7 plus 22x plus 33. That. And again, no one's going to let me leave it like that. So I'm going to combine the x's. I'm going to get 57x, like that, plus 40, like that. And we can multiply out the bottom if we want to. How about we make it 14x plus 21. And this is pretty much all the kinds of inputs that we have to be able to do in calculus and every course after. So this is something we wanted to practice. That's why we wanted to show this one.